So secant is the sister to who? Cosine, okay? So that's really important because in order to graph secant, I am going to graph the cosine wave. Okay, so I'm going to graph cosine, but I don't want you to connect the points. I just want you to plot the points for cosine, but don't connect it yet, okay? So cosine, the cosine of 0 degrees is what? Where does cosine start? Does cosine start at the top or the middle? Cosine, what's the cosine of 0 degrees? Look at your unit circle. You're not sure. Cosine of 0 degrees. Cosine is 1. Okay, cosine is the x value. So put a point at 1. And then I'm going to scale by 45s again. So let me write that down. I'm scaling by 45. Okay, so now I'm going to go to 90 degrees. So what's the cosine of 90 degrees? Is it 1, 0, or negative 1? 0. Cosine of 180? Negative 1. So here's our pattern. And I'm just going to do the entire graph. And we're not going to connect these points. Okay, secant is undefined. Okay, so it's undefined, or you have an asymptote where cosine is equal to 0. And let's talk about why is secant undefined. So every place where I put a point on the midline, we have an asymptote. So every single place where you put a point at 0, I want you to draw an asymptote in. So I'm going to draw my asymptote in. I'm going to do red. Every time you put a point on at 0, every time you put a point where y is equal to 0, draw in an asymptote. And we'll talk about why we have an asymptote. So secant has a vertical asymptote every time cosine is equal to 0. And let's talk about why that is. 0 is really, can be written as a fraction. The number 0 can be written as 0 over 1. Okay, so every time cosine is 0, we get 0 over 1. That's really 0 over 1. Remember, secant is the reciprocal. So what happens when I flip 0 over 1? It becomes what? 1 over 0, which is undefined. Okay, so this is undefined, which is why secant has an asymptote every place where cosine is equal to 0. This is undefined. So if the cosine is equal to this, the secant equals 1 over 0. So if cosine is 0 over 1, secant is 1 over 0, which is undefined. And that's why we have to draw asymptotes in. Okay. So it looks like parabolas, even though it's not parabolas. But every time you have a point at 1, I want you to draw, it looks like a parabola, but it's technically not. So every time you have a point at 1, make a parabola going up. And then every time you have a point at -1, you make a parabola going down. And this is what your graph looks like. And the reason why I say it's not a parabola is because it's not going outside of those asymptotes. Okay, so now let's fill in our critical information. So your domain, because we have asymptotes, it is no longer all real numbers. We have to add what's excluded. But I think it's easier to start with our asymptotes and then do our domain. So let's start with our asymptotes. So my first asymptote is at x equals, where is this at? What value is this? Where is the first place where cosine was undefined? What is that? What does this angle right here represent? 90 degrees, right? So at 90 degrees, that's the first place where cosine is undefined. And how do you write 90 in radians? Because we're going to do everything in radians. Pi over 2. So at x equals pi over 2, plus and minus, because it's going in the same direction, what's the distance? How many degrees between every asymptote? So we started at pi over 2, and then how many degrees before we hit another one? What's the distance between my two asymptotes is what I'm asking. So we have one at 90, and then our next one is at 270. What's the distance between 90 and 270? 180, right? And how do you write 180 in radians? Pi. So your asymptotes are, and I'm going to write that a little bit bigger because I feel like for those in the back, you might not be able to see that. X equals pi over 2 plus and minus pi, and we put an in there because that's repeating every 180 degrees. And it's positive, so we're going to the right 180 and to the left 180. That's every place where we have an asymptote. My domain is all real numbers, but you have to say that x cannot equal, so I'm going to just write this. X cannot equal pi over 2 plus or minus pi n. So that's why I usually start with the asymptote, because we're going to use that for my domain. The range, so for this upside down, we'll start with the upside down one. That would be negative infinity to what? What is that y value equal right here? -1, so negative infinity to -1 with a bracket, union, and then we have this one, which starts at +1 and goes towards positive infinity. Your period is still 2 pi over b. So secant and cosecant, we still use the same formula. So the period is still 2 pi over b. And b is the number in front of x, which in this parent function is a 1. So it's just 2 pi divided by 1, which is 2 pi. And secant and cosecant, we don't have amplitude. So that's the NA. Okay, so let's go ahead and graph cosecant. So who's cosecant the sister for? For sine, yep. So go ahead and plot your points for sine. Don't connect it, but plot your points for sine. Sine starts at 0. And then the sine of 90 is 1, and the sine of 180 is back to 0. This here is 270. That's -1. So, and then back to 360 is at 0. So I'm going to go both directions and fill in my wave. So remember that every time that's sine, whenever sine equals 0, cosecant equals 1 over 0. So just like with the last one, I want you to draw your asymptotes in every place where you have a point at 0. So go ahead, draw your asymptotes. When you hit 1, draw an upside or a smile. And when you're at -1, you have your frown. So and then we're going to write our equation for our asymptotes. So we have our first asymptote at 0. So x equals 0, plus or minus. What's the distance between our asymptotes? It's the same as secant. 180 degrees, which would be pi n. So that n just says that we're repeatedly adding and subtracting pi. So that's my asymptote. When we write our domain, it's all real numbers, but then you say x cannot equal, and I'm just going to rewrite my asymptote statement, 0 plus or minus pi n. Your range of cosecant is the same as your range for secant. It's -infinity to -1, bracket on the -1, union 1 to positive infinity. The period is still 2 pi over b. And then the parent function, b is still 1, so your period is still 2 pi. Amplitude is the height from the center. And because this graph goes up towards positive infinity and down towards negative infinity, that's why we don't have that. It's NA. So let's do one more. And then I want to give you time to work on homework 4 and get your questions answered. So I think the easiest way is just to realize that we're going to plot the points as if we're graphing the sine. So we're going to graph 2 times the sine of x plus pi over 2, because that's the sister to cosecant. So essentially, we're following the same steps that we follow to graph sine and cosine. So the first thing we're going to do is figure out our phase shift, because now it has a shift. Take your parentheses, set that equal to 0. And you should get negative pi over 2. And it's negative, so we're going to go to the left. So where it says phase shift, right, left, pi over 2. So I'm going to start it here. I'm counting by 45. So this is negative 90 degrees. So that's where I'm going to start my wave. The period tells me how far from this I'm going to end. So how far from my start do I end? And because the b value in this example is 1, the period is 2 pi divided by 1, which is still 2 pi. So let's write that down for our period. So I'm starting here, and I'm ending 360 degrees later. So that would be 8 hops. So 1, 2, 3, 4. I can't count up there. I got to go over there. Sorry. So we got 1, 2, 3, 6. So right here. So the distance between negative, so from here to here, should be 2 pi. So sine starts in the middle. We go middle, top, middle, bottom, back to the middle. So the middle is k. What is k? 0. So there's an invisible plus 0 back here. So that's my midline. So where it says vertical shift, say we don't have any because it's k. K is 0. So it doesn't go up or down. So I'm going to put a point at 0 at the start and at my end, and then directly in the center. Now the amplitude tells me how far I need to go up. So what's the amplitude of this wave? 2. So from here, in between here, remember, the sine pattern says you start at the middle, then you go up to the top, back to the middle, hit the bottom of the wave, back to the middle. So I'm going to start here. So to go up to the top, I need to go up 2. So put a point right there. And the bottom of my wave, I need to go down 2 and put a point. So let's continue our pattern. So here I'm going to rotate out 90 degrees. I'm going to hit the 2 again. Rotate out 90 back to 0. Here I'm going to rotate to the left 90 degrees. Go down to -2. Rotate out 90 back to 0. The 2. Okay. So my midline is at 0. So every place, because now we're not going to connect this, right? Because we're not graphing the sine wave, so we don't want that. We're graphing the sister. So every time you hit the middle, which is 0, I need you to draw an asymptote. Yep. I need to take off some of this stuff. Okay, so now every time you hit the top of the wave, make a parabola that faces up. So every time you hit +2, you have an up parabola. And every time you hit -2, you have a down. Upside down parabola. So we're going to draw those in. And that is your graph. So only because I feel like I need more space, I'm going to write the vertical asymptotes down here at the bottom. You don't have to do that on yours, but for mine, I feel like I need a little bit more space. So, okay, so for vertical asymptote, where do we have our first vertical asymptote at? Over here. So we don't have one at 0. So what is this angle right here? Pi/2. X equals pi/2 plus or minus what? Pi. Yep. That's my vertical asymptote. So my domain is all real numbers. X cannot equal pi/2 plus or minus pi. Your range is -infinity to -2 with a bracket. 2 to infinity. We don't have an amplitude. All right, so go ahead, take out homework 4. Let's work on that. Get your questions answered. You have 2 people to help you. That is due tomorrow.